Alright guys, so now what we're going to do here is I explained you the second law, Newton's second law, and now what we're going to do, we're going to solve some problems on Newton's second law. And the example that I want to solve today with you guys, and it's going to be just one of the examples, is follows. I actually came up with the names of my kids. They usually don't fight, but you know, I just wanted to create a problem that will involve that we can actually solve on the topics or concepts of Newton's second law. So here's the problem. So Andre is holding a toy with a mass of 0.25 kilogram. When Nicole decides to pull it away from Andre, if Andre pulls horizontally on the toy with a force of 9 newtons and Nicole pulls with the horizontal force 12 newtons, what is the horizontal acceleration of the toy? All right, so the first thing, guys, what I want to do is, again, I'm not going to have enough space here to solve it, so we'll have to erase this problem. And again, since you have a video here, so you can always go back and you know, check the problems, you know, the problem itself, you know, the, I guess, the what's given and what needs to be found. So the first thing I always want to do in physics as we solve problems is to state what's given. So this is what I got is given. So I got the mass of the toy, 0.25 kilograms. I got here force, I guess, that Andre pulls. I'm gonna put FA, designated Andre, and he pulls it with the force of 9 newtons here, 9 newtons. And then I got also force that Nicole pulls, and she's a, you know, bigger child, so she pulls with a greater force. Now the question is, what is the horizontal acceleration? A is equal question mark. And of course, the way we're going to solve this problem is we're going to use F is equal to, and I'm going to put a little net in here, because let me just fix this real quick. And the reason we need to find F net is because if they actually pulling with the same force, then this toy will be at equilibrium, and because both forces will cancel each other, and so your velocity will be 0. There's going to be, I mean, change in velocity will be 0, and your acceleration will be 0 here, and so there's going to be no net force. But in this particular case, of course, when you use second law of Newton, you always have to be cognizant to find the net force here, because that's what will be acting on the body, on the object. And so so F net is equal to M times A. Okay, very good. So the only thing we have to find here, we're given the mass, we need to find F net. So how do we do it? First, I'm going to do the visual here, and I'm going to make this dot as a toy, and I'm going to put Nicole is pulling 12, so I'm going to put F sub n, 12 newtons, and then I'm going to put Andre a little smaller. Remember, the force is a vector, has magnitude and direction. Let's say this is about 9, so FA is equal to 9 newtons. So how do I find, guys, the F net? Well, remember, guys, when we have to add the vectors, so F net will be nothing else as the what? As the F Nicole plus minus, because they're pulling opposite direction, this vector has to be flipped, Andre. Okay, now, all right, how do we do it visually now? So let me do it here. So this is my vector by Nicole, my force right here, her force, not mine force, her force. And then I'm doing next is I'm going to flip now. So this is the F Nicole, and this will be now here the other way, will be a little smaller, let's say. Let me do a little smaller. So this will be here now, Andre will be minus F Andre. And so, of course, guys, remember how we find the F, resultant force, or F net. So we get from the tail of the first vector, and we're going to get to the head of the second one, and that will be our F net. F net. All right, so let's solve this problem. So F net is equal to, now what's the force Nicole exerts on the toy? 12 newtons minus 9 newtons, or I should say plus minus, just let's keep it, you know, same as the formula, Newton, and so the answer here will be 3 newtons. Okay, by the way, I think I forgot to mention how you derive Newton, and it's pretty simple here. Let me just show it to you guys. So F, from the previous discussion, I derived the Newton's second law, F is equal to m times a, and so the force, if we just plug the units here, will be the mass in kilograms, and acceleration will be meter divided by second square. So that will be equal to just Newton, okay? Just if I forgot to mention it before, so that will be the derivation of the Newton. Okay, so almost there. So now we got the F net, so we just pretty much just plug everything in. So we now have the 3 here. Let me just move this a little, you know, in the focus of the camera. So we got 3 newtons. We know that the Newton is a kilogram times mass divided by second square, and that will be equal to now the mass is already in kilograms, 0.25 kilogram times acceleration. So you can see, guys, here kilograms and kilograms can cancel right away. So I really don't have space here, so let me just I'm working on getting some better technology here, so you gotta, guys, give me some time, but I'm gonna continue right here. So now all I have to do now is to say that A by cross multiplying is equal to 3, I cancel the kilograms, meter per second, and then that would be divided by 0.25. All I have to do now, find out the acceleration. I just have to use a calculator, just real quick. I'm going to plug everything in. So I'm going to say 3 divided by 0.25, and since I have one significant figure here, my answer here is 12. 12 meters per second. Let me just make sure that I did the right calculations here. 3 divided by 0.25. Yeah, that's correct. But since it's only one significant figure, so I'm going to report this as a 10 meters per, by the way, I forgot, it was second square. Okay, so the final answer will be 10 meter per second square, and again it's 12, but since I only had one significant figure here in the number 3, so I had to round it off this one to just the tens, and so when I do so, 2 I have to drop, and since it's less than a 5, so this preceding number will just stay the same, which is 10.